right, I think I'm live. So this should be fine. So okay, let's zoom in. Let's see where we are yesterday. On Jan, on 8th Jan 2026, we have written instruction to create mint with transfer hook extension. We already have written the transfer hook program, and we wrote our instruction to create the mint, and the transfer hook program is a program that we have developed. Now the next steps for today is basically to write the test. The test should create the mint with transfer hook extension. We should create the um, extra account metas. We should create the counter PDA to count the number of transfers happening for tokens of that particular mint. We create the ATS, basically simulate two users. That means create two ATS associated token accounts, mint to these two ATS, and perform a transfer from one ATA to another. Then we will check the PDA, counter PDA, to see if the count has increased to one or not. So that is it, right? We create the counter PDA. When we initialize it, the count will basically be zero. We basically perform a transfer and don't manually kind of like touch the counter PDA, and the transfer itself will call the transfer hook program's execute instruction. If I repeatedly open librs of transfer hook and go to the execute instruction, there itself, we should be able to, the execute instruction basically gets executed, and we see the counter incremented by one. And likewise, we perform another transfer, and then we should be able to check whether the counter PDA's count has increased to, two or not. So yeah, that's like the high level gist. Let me also copy this one to the test file. So here's my Launchpad test TS file. I'll ensure everything is in place first. So cd anchor. I I'll ensure that I have a successful anchor build right now, and also run like the existing tests are passing so that I don't um, mess with like something I haven't touched. Okay, anchor build is good, I guess. Yeah, let me run the anchor test. I'm just checking my anchor toml whether I have included the transfer hook program or not. We have included in our anchor toml. There is a warning. Let's ignore that. Sorry, wrong directory. Solana, Solana token 2022 launchpad, CD anchor build. Okay, anchor build is good. Let me run the test for the create token with metadata and create token with fee transfer fee extension. I just want them running and being passed. So yeah, all good. So let's go ahead and write the new test. So describe uh, create token with transfer hook. Write a test case. Should execute transfer hook on token transfer. So yeah, let's just follow these notes itself. So like we always do, step one, token params, const token name. Let's name this token counter hook token. Give the token symbol. Give the token URI. I'll pass it as empty. Const token decimals. Keeping it as 9. Get the mint key pair. Key pair, just generate one. And we are transferring from uh, one person's wallet to another person's wallet. So let's keep the first person from whom we are kind of like transferring the token as a pair itself, whatever the anchor pair that we have from the provider. So let's use that and let's create another one for like, let's create a new one for like the recipient. So just generate a new key pair. And yeah, that itself is done. Now create the mint with transfer hook extension using the instruction that we have created. So const init counter instruction equals like just RPC it, right? So transaction program dot methods dot create token with transfer hook. I can open the types by the side. Launchpad.ts create token with transfer hook. Standard arguments, token name, token symbol, token symbol, token URI, token decimals, and transfer hook program ID. So from where will I get this transfer hook program ID? Just get this from the Libris. You have the basically this one. So let me declare this one here as well. transfer hook program ID here. Or else, let's do one more thing here. If I open the test file here, see we have imported this, you know, the Launchpad program as like Anchor Workspace Launchpad as program Launchpad. I think we can do the same thing here. So do like transfer hook program anchor.workspace.transfer. Yeah, we should get like transfer hook as program transfer. Let's see. Let's inspect the build folder to see how we can get this transfer hook types. Transfer, yeah, target types, right? So open target types. Yeah, I have like the transfer hook right here. So yeah, just import that from here. Have transfer hook here. Yeah, that itself, that is it all I want. So I don't need to kind of like hard code it here now. So I can just pass in like transfer hook program dot program ID. Again, I can open the types transfer hook dot ts. I have like the address here or the program ID. Program ID. Yeah, this is fine for now. No. Let's proceed with writing this transaction. Now accounts, use autocomplete. First the payer. So payer dot public key, and then the mint account, the mint key pair that we just created, public key. Token program. So give the token 2022 program, and then the system program dot program ID, and then keep the signers as the mint key pair and send the instruction commitment confirmed. I do want to catch some issues if at all we encounter any failure in the instruction execution. Transaction error. Yeah, and just wait for the transaction to get just confirmed. Provider dot connection dot confirm transaction. Passing the transaction, not the initial init counter, init mint. Initialize mint transaction confirmed. Why is this throwing an error? Let's not catch errors. Yeah. Now what we need to do is like derive the extra account metas PDA list and the counter PDA, and just keep those addresses ready. So derive extra accounts meta list PDA address plus counter PDA address. So const extra account meta list PDA is public key dot find address sync, and then you have uh, what do we need to pass? We need to pass those seats extra. So what I'm doing here is like if I open the transfer program, so okay, not, yeah, basically this zone. So I'm just kind of like deriving this period. Let me declare this. Say as like in the contract. Let me copy the counter seed as well. Yeah, what else? Just mint key is nothing but mint key pair dot public key dot to base 58. Yeah, this must be it. And yeah, this is it with regards to the transfer hook program. So pass that program ID. I think we need to pass this as buffer. So let's keep it like buffer dot from. Instead of 2 base 56, I think there must be some 2 buffer. Yeah. Okay, you have the extra account meta PDA list address, and you need the counter PDA now. So counter PDA public key dot find address sync, um, pass in the mint key pair dot public key dot to buffer, and find pass in the counter set. What did I basically do here? If I again go back to the transfer program, if I look at how we are deriving the counter PDA, go to the context, initialize counter. Where are you initializing the counter? You are initializing it at mint address. I mean, like the seats are basically at the mint address, comma, the counter seat. So the mint address, comma, the counter seat. So that's basically it. And this is regarding to transfer hook program. Dot program ID. Yeah, this is also needs to be changed to buffer dot from. All good. So now let's go ahead and initialize the extra account meta list using our instruction. Here again, you have an instruction called initialize extra account meta list. Why do we need to initialize this? Because this holds the address to the counter PDA, which is required by the execute instruction. We've like discussed this multiple times, but yeah. Um, let's call that instruction const init extra account meta list transaction await transfer hook program dot methods dot initialize extra account meta list. Let me grab this. Passing the arguments. There are no arguments, so directly passing the accounts. I think pair dot public key. You have the mint key pair public key. You have the extra accounts. Let me simply open these types transfer hook dot ts initialize extra account meta list instruction. In the accounts, we need to pass this extra account meta list. So pass the one we just derived, PDA address, and what else? System program. System program dot program ID. It is throwing an issue. It sometimes can also derive from uh, here from this context, if I go here, yeah, it can automatically kind of like derive this one, and we don't explicitly need to kind of like pass this in. So it's a choice at this moment. So I can just comment this one out and not pass it at all. That's also fine. Uh, just to explain like why am I getting this warning or like the lint error basically. So okay, let me pass this transaction over the network. Commitment confirmed, and wait for this transaction to get confirmed. Provider dot connection confirm transaction confirmed. All right. Now you need to initialize the transfer counter, the counter PDA basically. Um, yeah, let's initialize that one as well. So const init counter transaction equals to transfer hook program methods initialize counter. Do we need to pass any arguments to this? Create counter. Sorry, initialize counter, no arguments. Accounts. What all accounts does it need? So it takes a sign. Okay. Signer pair dot pair. Sorry, pair dot public key. You have the mint key pair dot public key. You have the counter. Again, I can pass it, or the context itself can derive this. So I'm just passing it for now. System program dot program ID. Send this transaction over the network. Commitment confirmed. Wait for this transaction to get confirmed. Await provider dot connection. Confirm transaction. Confirmed. Yeah. Now what we'll do is like we'll verify the counter PDA is 0. Okay, so what have we done till now? So if I zoom out a little bit, this must be too small. Again, what are our steps? We want to create the mint with transfer hook extension, um, create the extra account metas list so that it holds the counter PDA address. We need to create the counter PDA or initialize the counter PDA. So this is probably till now what we have done. We are now checking that, hey, whether the counter PDA's value is 0. Next, we'll move on to kind of like simulating the users, performing a transfer, and then checking whether this counter PDA's value changes to, the number of transfers we do. So let's quickly fetch it. So initial counter is equals to await transfer hook program. In this program again, if I go to librs, yeah, I have this account structure. So I'll basically use like transfer counter here. Transfer accounts, account dot, account dot transfer counter, and fetch it counter PD. All good. Now we'll just expect it here or just log it down. Console.log initial counter value is initial counter. .com. We'll just log it to see how it is, and then we'll kind of like add a testing rule here. Expect initial counter dot count to equal 0. We haven't performed any transfer, so the counter PDA should be 0 here. And now what we'll do is like we'll create the basically like simulating the users performing a transfer. We create the ATS for sender and receiver. So the sender is nothing but the payer itself. So let's get the ATA addresses first and then initialize the ATS. So first sender ATA equals to get associated token address sync for which, okay, yeah, the mint key pair, mint key pair dot public key. Owner is a payer. The sender is a payer. Allow off-chain false. Program ID, token 2022 program ID. Similarly, let's do an receiver ATA as well. We have initialized the receiver key pair above. Where is it? Yeah, we mentioned it like recipient. So let's go here. I'll just change it to like a receiver. Otherwise, receiver key pair. So this is good. You basically know the ATS live here, but the ATS aren't like created. So just create them. Create the ATS. Now create sender ATA instruction. Create associated token account instruction. Payer dot public key. Associated token, which is associated token is nothing but the associated token account address. So sender ATA, owner is the payer, mint, public key, program ID token 2020. Let's create the instruction for receiver as well. Wait, this is the fee payer, sorry. Payer dot public key. And here you want the receiver key payer dot public key. So again, create ATS, just send those instructions as a transaction. New transaction. Transaction Solana Web3.js. Dot add these both instructions. Const create ATS signature is await send and confirm transaction. Not raw transaction. It takes the connection. So provider dot connection. Create ATS transaction. It takes signers. Just the payer is the signer now. Payer dot public key. And what all options do we need? We just need the commitment to be confirmed. It is saying and signers should be an array. Okay, we'll make it an array. And it's not the public key, it's a signer. So payer. This should be fine. Yeah, the transaction will be confirmed here. And now what we'll do is like mint tokens to the sender's ATA. How many tokens do we want to send? Mint amount. Let's do like 1,000 tokens. Yeah, I need to count zeros now. 1,000 tokens. So new BM first 1,000. And the we have declared like the token decimals to be 9. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 9. So this is like 1,000 tokens. Now mint these tokens to the sender's ATA. So construct a mint to instruction, create mint to instruction. I think that's the one you need. What does it take? The mint key pair, public key, destination, the sender ATA, the authority is the payer, the amount, the mint amount we just declared, multi signers, no, program ID, token 2022 program ID. Why is this shouting? BM is not assignable to a parameter of type number and begin. So change this to begin. And now send this over the network as we did like here. New transaction add, send on confirm. Const minter to transaction, new transaction dot add mint to instruction, and get the mint to signature. So I will send and confirm transaction, provider dot connection. Okay, what mint to transaction, signers, the payer itself is the signer again, and commitment confirm. Yeah. Okay. Now what we'll do is basically transfer tokens from sender to receiver. This will automatically will invoke the transfer hook program, and the counter PDS count should increase by 1. So that's what we want to check. So transfer amount, let's transfer like 10 tokens. So that would be like the int 10 and 9 zeros, 1, 2, 3, 1, 2, 3, 1, 2, 3. And yeah, create a transfer instruction, transfer instruction, create transfer. Yeah, there is this function, create transfer checked with transfer hook instruction. Let's use this one. Provider dot connection from sender ATA, mint key pair public key, destination is receivers ATA, owner is the payer, owner of the ATA, and the amount is the transfer amount we just declared, the token decimals, multi-signers no, commitment confirmed, token 2022 program ID. Now passing the transfer transaction, basically send it over the network. So new transaction, dot add transfer instruction and send it and confirm. Transfer transaction signature, send and confirm transaction, transfer transaction. Oh, provider connection transaction, signers the payer, options, commitment, confirmed. All right. Now we need to finally verify the counter. Uh, it's basically we just need to verify that the our libbar is also the transfer hook programs execute instruction has been executed or not. So yeah, that's what basically do. And how will we do that is basically by verifying the uh, counter PDA's counter value being incremented to 1. So again, now fetch the final counter value, counter PDA, let's say, public key. Why am I doing public key? No, sorry, await transfer hook program account transfer counter dot fetch counter PDA. Now we need to expect that. Expect final counter dot count to equal to be 1. So this is what we want. I also want to see the logs of the transfer function, but yeah, this is all right. Transfer. Okay, let's do this way. Let's run the test. Okay. Oh, successfully failed. Received 0, 0. Okay, let's change to 0, 0. How does it go to be 0, 0? Some value mapping. Okay. Oh, we get it in the string format. Okay. Why do I need to do it in this line? I can do it like to number and make it equal to 0. And same thing here as well. To number equal to awesome. Process instruction provided seats do not result in a valid address. Create ATS signature. Okay. Create. Let's see. Okay. We created super ATS here again. Awesome. So yeah, the transfer has happened from A to B, and this execute instruction has been executed automatically, and um, yeah, the counter has increased. So let's look for this done message in our local explorer instead of using anchor validator. So I'll kind of like spin up a local validator, Solana test validator, and then anchor test skip local validator. What I'm looking to grab from the test logs is the transfer transaction signature. Those transfer transaction logs will have a CPI call to the transfer hook program running the execute instruction. That's what I want to see on the Explorer, and that's how we basically see, you know, transfer being executed there. So transfer transaction sign. If I go and open the browser, low, okay, explorer.solana.com, connect it to my local validator, give it the transfer signature. So this is like the transfer signature that just got executed. Yes, look over here. This is awesome. So we basically perform the transfer checked instruction. Where did we do this? We did this at send and sorry, create transfer check with transfer quick extension. So we perform this transfer checked instruction. The program is invoked. This program, this is nothing but our uh, transfer hook program. So librs transfer hook, you know, transfer hook, this program. It didn't execute the execute instruction directly, but it executed the fallback instruction. So fallback, and we got this from fallback log here from fallback. And then you got like the instruction execute, which, when this raw data got unpacked with the transfer hook extension, it matched with the transfer hook extension's execute instruction with the discriminator, everything in place. Yeah, from the bytes, we got the amount and passed it to the execute instruction here. And we derived the counter from the extra icons meta list, which we grabbed it here. We incremented the count. We logged the message done. So if I look at here, the message we get here is like done. Yeah, and the program completed so and so CUs, return success. This entire thing happened in the CPA call. We return back to the main level and again return success, and the transfer has happened there. So yeah, that's about the transfer implementation. So if I go to the notes again, we are like probably done with transfer hook at this moment. Again, like the next steps would be either add more extensions, popular ones, or we start writing the UI plus UX plus wallet integrations to kind of like spin up the entire pump.fun like UI to create tokens on the launchpad. So we do have like this is like the anchor folder in our repo, but we do have like the Next.js setup ready. So uh, I'll probably take a call whether we want to add like a few more extensions and then jump into the UI. The UI UX work would be very simple to be very honest, not that exciting to me. So yeah, let me see. If I want to add more extensions, I'll probably add more extensions and like uh, yeah, just uh, and then start the UI UX, or I'll just directly do some UI UX, deploy it, and then kind of like iteratively add more extensions. But yeah, that's it for today. And yeah, I'll make a call on what to do next.